Now we are continuing with the previous lecture. In that I told you how to calculate the inverse. Now certain theorems we should know on this inverse that I'll tell, and then we'll come on more questions on inverse. First theorem is called as cancellation law. What this cancellation law says, that if you have three matrices A, B and C, all are square matrices with same order, with same order, then, and if we have AB is equal to AC, A is on the left side of B here and left side of C. So this is a pre-multiplier, this is a pre-multiplier. Then cancellation law says this implies B is equal to C, where determinant A should not be 0. This is called cancellation law. How we just get this result, just I'll tell you. AB equal to AC we have. As I want to remove A, I take A inverse of this. A, B and then A inverse A into C. This property already I told you, A if multiply with its inverse is come identity. A inverse A is again identity. So A inverse we are multiplying both the side. When you do this, associative property already I told you. So this will come out to be identity into B and this will be identity into C. And this come out to be B is equal to C. Only when A inverse exists. Because you are applying A inverse on both sides, you are multiplying A inverse on both sides, that means inverse should exist. And if that exists, then only we are going to get B is equal to C. And in what case A inverse exists? I told earlier A inverse is adjoint of A by determinant A. Then I told you this quantity should not be 0. So only when A inverse exists. A inverse exists, what does it mean? This implies determinant A should not be 0. Means A should be a non-singular matrix. So this is called cancellation law. So AB is equal to AC, then B is equal to C, where determinant A should not be 0. Or you can say A inverse exists, or you can say A will be a non-singular matrix. Then this will be cancellation law, which is valid. Other cancellation law is also there. This is called left cancellation. Same way if I give this way, then this is called right cancellation. In that case, what I do here, B A inverse, C A inverse. And then clearly this part is identity, this part is identity, BI will be CI, or we'll say B is equal to C. Only when what? A inverse exists. And A inverse exists means what? Determinant A should not be 0. So this is called cancellation law. One is left cancellation, another is right cancellation law. Second theorem says if you have A and B, two matrices, and take the inverse of it. First you multiply the matrix and then you take inverse, will be same as inverse of first B and then inverse of A. This is another important property you should keep in mind. By the way, if it is 3 ABC inverse, then it will come C inverse, B inverse, A inverse. This is called another theorem in which inverse can be separated. Third theorem, theorem number third. This is theorem number 2. This is theorem number 3. Theorem number 3 says that if you take A inverse whole transpose, if you take A inverse whole transpose, then it can be also taken as A transpose inverse. Inverse First you take and then take transpose, or you take transpose and then you take inverse, the result come out to be same. So this way you will be having these three theorems. More theorems are there, but that will be we'll be doing after completing determinant, because determinant we left in between. So first we'll complete that and then we will be coming on more theorems. Now coming on questions. Right, next question please. Question says, if B is any matrix, B into 1 minus 2, 1 and 4 is equal to 6006. B is any matrix. What order? That you decide. It will be 2 by 2 matrix given. Okay. Question is, B is a matrix of order 2 by 2. Then find out what is B if B into this is given this result. How you calculate? Just check. Let this matrix be A. So I write down B into A will be. Will 6 be common in it? Yes. So I say 6 common. Then left is 1001. And then we will write B A will be 6 of I. Yes or no? Now I want B to be calculated. B to be calculated means A should be removed from here. And that you can remove by using inverse. So multiplying inverse on both sides. When you do this, A into A inverse, what that will come? B into I. And 6, A inverse I will be 6 of A inverse. And then B can be calculated easily, 6A inverse. Now A inverse you can calculate. What is your A? A is here. 1 minus 2, 1 and 4. And if you want the inverse of it, what you should have? Adjoint A by determinant A. First I calculate what is determinant A. It will be 4 plus 2. Come out to be 6. So we got determinant A not 0. That means we'll say yes, inverse will exist. Then we go on adjoint of A. I'm doing it directly now. Adjoint when I should take the cofactors. So when you take this element, cofactor will be 4. When you take this element, the cofactor will be minus 1 because this is 2, 1 element. When you take this element, the cofactor will be simply 2. And when you take this 4 element, then the cofactor will be 1 and then take transpose. Now when you do this, what is adjoint we got now? Adjoint we got, determinant we got. So we will say it will be 1 by 6. That is determinant A. And then this will be 4, 2, minus 1 and 1. This is your A inverse. And now they are asking what is B. So B we can calculate easily. 6 into A inverse. That will be 1 by 6. Then 4, 2, minus 1 and 1. Your result is coming 4, 2, minus 1 and 1. This is your B, unknown matrix. So you can calculate unknown matrix easily. Same way, one more question is there that you try, only the hint I am giving to you. This is another good question. If this condition is given to you, 2, 1, 3, 2, this is matrix A, order 2 by 2, then it is minus 3, 2, then 5 and minus 3 equal to 1, 0, 0, 1. Now my question is, find out what is matrix A. This time they are asking what is matrix A. A is a matrix, not a number. So, and one more thing, you can't take this here or this here because commutative property in general does not hold. Keep in mind, don't say that A, I can take this side and I'll take this term here and multiply. That cannot be done. So first thing what I do here, let this be B. A, C is coming identity. Is it right? What you want in the question, you want A. So what I do here, I want to remove B and I want to remove C. So I go for B inverse B. A C into C inverse is B inverse I C inverse. Now when you solve it, it will be identity, it will be identity. So it will be identity A and this is identity comes out to be B inverse and C inverse. This is nothing but A and this is B inverse C inverse. So either you do one thing, B inverse, this is B, inverse of this you calculate, inverse of this you calculate and then multiply. Or you can do this way also, just now I told this property, this is CB power minus 1. That means CB inverse, means first you multiply C and B and then take inverse of it. So anyway you can do it, individually B inverse, C inverse you calculate, multiply them in the same order, or C into B you take first and then take inverse, you will get your matrix A. So this is another question we have. We'll continue in the next lesson, more problems on this. Thank you.